James Webb Space Telescope is not a replacement for the aging and highly successful Hubble. That is not exactly correct, and the comparison mistakes the way each telescope works. While the Hubble concentrates on visible light, JWST is sensitive to infrared. The Hubble is still top dog when it comes to the visible spectrum, but the James Webb extends astronomers' powers of observation by effectively imaging infrared light. It gives scientists the means to look into a point much farther in time, shortly after the universe started and the very first stars and galaxies that started to burn. It also gives astronomers the ability to directly image exoplanets, planets that orbit stars other than our own. So on July 12th, the James Webb Telescope released its first images to great fanfare. The images were noteworthy, more for their beauty than their immediate scientific value. They included distant galaxies, including Stephan's Quintet, a group of 5 galaxies that appeared in the Christmas classic It's a Wonderful Life. They showed stars being born and one that was dying. One image shows water in the atmosphere of a distant planet. These images certainly had a fantastic gee whiz factor. But now it's time for scientists to settle down to the work of producing scientific discoveries and publishing their findings. While every scientist has their favorite astronomical body to image, one of the most anticipated avenues of research James Webb has opened up is the ability to explore what only infrared light can reveal. The history of the universe begins with the Big Bang, which was followed by a period of time during which the universe was really hot and glowing. This initial hot period was when hydrogen and helium, the primordial elements that made up the early universe, were formed. So as the universe expanded and cooled, its initial glow faded away. About 380,000 years after the Big Bang, the universe went totally dark. So dark indeed that astronomers call this the period the cosmic dark ages. It was during that time that hydrogen and helium condensed. After 100 million to 200 million years, clouds of hydrogen and helium became so dense, so hot, that they actually began to go nuclear fusion. And this is how the first stars were born. These stars were monsters. They were hundreds of times bigger than the sun, and they shone white hot, but they lived really short lives. You would think seeing them would be easy. They're bright and unmistakable beacons from the beginnings of the time, but the universe plays tricks on us. James Webb pictures the universe as a baby. The universe has been expanding since it began with the Big Bang. As it expands, it also stretches out the light that travels through it. The universe's first bright blue-white stars emitted light in very short wavelengths. However, the expansion of the universe stretched that short wavelength blue light into a longer wavelength, green, then longer still to yellow, and finally orange and red. Stretched further still, the light of primordial stars reached infrared. This part of the spectrum is invisible to the human eye and even to the venerable Hubble Space Telescope, but it is exactly what the James Webb was designed to capture and render. Thus, James Webb will be able to see the first stars and galaxies, celestial bodies that were formed just a few 100 million years after the Big Bang. While the data James Webb has obtained so far is remarkably new and fresh, researchers have already reported seeing 2 incredibly distant and therefore incredibly old galaxies. These galaxies existed about 300 million to 400 million years after the universe began, when it was just 2% to 3% of its current age. If we think of the universe as a 40-year-old person, the pictures of these galaxies are showing us the universe as a 1-year-old. Quite literally, the James Webb has taken baby pictures of the cosmos. This is only the beginning of the story. 2 other teams of researchers actually claim they've found even more distant older galaxies that formed perhaps as early as 100 million years after the Big Bang. In a year or 2, we may have images of the first stars. It's important to remember the treasure trove of knowledge the Hubble Space Telescope revealed to us when we think about what we can expect to learn from James Webb data in the future. Hubble was launched in 1990 and it has been operating for 3 decades. During this time, it has revolutionized our ideas of astronomy more than once. In contrast, James Webb's data has been available to professional astronomers for only a couple of months. There is a long future ahead of it. James Webb is expected to operate for 5 to 10 years before it uses up the onboard consumables that keep it operational. Astronomers expect an explosion of new results over the next several years. These first ancient galaxies are just the start. There's also a lot of things Webb will continue to prove. If you want to know the Einstein theories and equations that Webb will prove, then check out this video here. Otherwise, I'll see you in the next one. Cheers.